going to be covering standard 1 and we're actually preparing for this standard. And the objective for this lesson is that you're going to be able to solve a simple and compound linear inequalities. So let's go ahead and take a look at some examples of linear inequalities. Alright, so you can see here that I have several examples of linear inequalities. And here we have x is less than or equal to 1. We have 3x minus 6 is greater than 9. And we have 3 times x minus 4, which is less than negative 6. Now, each one of these are just like a regular equation, except instead of the equal sign, we have an inequality. So let's go ahead and first look at how we can check to see if a given number is actually part of the solution. So here we have our first problem. 5 minus 3x is greater than or equal to negative 7. And we want to solve this for x equals 4. So what we're going to do is we're going to take 4 here and we're going to substitute it in for x. So what we end up with here is 5 minus 3x, and we know x is 4, so we substitute 4 in for x. Remember, whenever we substitute, we place it in parentheses, is greater than or equal to negative 7. Well, when we simplify this down even more, we get 5, negative 3 times 4 gives us negative 12, is greater than or equal to negative 7. And then 5 minus 12 gives us negative 7 is greater than or equal to negative 7. And what I want to do here is, you notice all I did was solve the one side of my inequality. So now I'm looking at this statement here, negative 7 is greater than or equal to negative 7. And what I want to do, or what we want to do is, we want to see if this statement is true. So is negative 7 greater than or equal to negative 7? Well, yes it is. So it's true. So we would say yes, it is a solution. Okay, and we would have our answer. Okay, if x is 4, yes, it is a solution to this inequality. So let's go ahead and take a look at another example. Alright, and for this example, we have 6x plus 2 is less than 14, and we want to see if this if 2 is a solution to this inequality. So we take 2 and we substitute it in for x. So we end up with 6 times 2, remember we place it in parentheses because we're substituting, plus 2 is less than 14. So 6 times 2 gives us 12. So 12 plus 2 is less than 14. And 12 plus 2 gives us 14. So 14 is less than 14. And we want to see if this statement is true. 14 is not less than 14 and is equal to. And since our inequality is not an equal to inequality, then this statement is false. So no, it is not a solution. And we have our solution here. Alright, so let's go ahead and take a look at our last one here. Okay, and for this one we have negative 2 is less than or equal to x plus 2, which is less than or equal to 5. And we want to see if this inequality is true if x would be negative 3. So just like we did on the previous two examples, we're going to take our x value and we're going to substitute it in for x. So we get negative 2 is less than or equal to negative 3, which is x, plus 2 is less than or equal to 5. And then we just want to simplify this. So we get negative 2 is less than or equal to negative 3 plus 2. which would be -1, which is less than or equal to 5. And basically, what we want to do here is we want to see if this -1 satisfies both of these inequalities here. So, looking at this first part here, -2 is less than or equal to -1. We want to see if this statement is true first. And yes, it is, because -2 is less than -1. So then we want to look at the right side here. So is -1 less than or equal to 5? Yes, it is. So because both of these inequalities are true, we're going to say they're both true. And we're going to say, yes, it is a solution. Now, if I did this and one of these inequalities was false, then this would be a false statement, and we would say, no, it's not a solution. All right. Well, now that we know how to check to see if a value is a solution to an inequality, let's go ahead and take a look at graphing simple linear inequalities. All right. And you can see here that when we graph, we're going to use what's called an open circle and a closed circle. And an open circle we're going to use if our inequality is less than or greater than. And an example of that would be x is greater than 2. Well, because our inequality is a greater than, we're going to use open circle. So we place an open circle at +2. And since x is everything greater than 2, we're going to shade to the right. And the reason for this is, and you're going to get used to this, anything that's greater than on a number line is always to the right. Anything less than is always to the left. And to check this, you can see here, +10 is greater than 2. So we would go towards the side that's greater than. All right, so let's take a look at the closed circle here. And for a closed circle, we would use a closed circle when our inequalities are less than equal to or greater than equal to. So let's take a look at an example of this. So here we have x is less than or equal to -1. So because it's a less than equal to inequality, we're going to use the closed circle. So we do a closed circle here at -1. And we want all the values of x that are less than that. So -4 is less than -1. So we're going to go all the way to the left here. And we graph our solution to the inequality. All right. And this is graphing in a nutshell. And we'll take a better look at this once we actually get into solving inequalities. Now, solving an inequality is basically done the same exact way as we would solve a regular equation. There's just one difference. And the only difference is that if you multiply or divide both sides by a negative number, make sure you key in on this one. A negative number, you have to multiply or divide both sides by a negative, you're going to flip or reverse the inequality. So let's go ahead and take a look at an example of each one of these. So here we have -2x is greater than or equal to 8. Well, in order to get rid of this -2, we would have to divide by -2. So what we do to one side, we do to the other. Remember, it has all the same, when we solve inequalities, we use the same properties as we would when we solve a regular equation. It's just, except for this rule right here. Okay? So we divide both sides by -2. Now, obviously these 2's cancel out, and we're left with x. But since we just divided by a negative number on both sides, we have to flip the inequality. So instead of being a greater than equal to, now it's a less than equal to. And it's 8 divided by -2, which gives us -4. And we would have our solution here. Okay? Another example here would be -1/3 x is less than or equal to -4. Well, in order to get rid of this -1/3 here, we have to multiply both sides by -3. And when we do that, these -3's cancel out, leaving us with 1x. And since we just multiplied both sides of the inequality by a negative number, we flip the inequality. So instead of being less than or equal to, it's a greater than or equal to negative 4 times negative 3, which is positive 12. And we would have our solution. All right? So let's go ahead and take a look at a couple simple linear inequalities and how we would actually solve these. All right, so for our first problem here, we have 11x minus 9 is greater than 13. Now, remember, we solve them just like we do a regular equation, except for our rule of multiplying and dividing by a negative number. So, the first thing we want to do here is we want to solve for x. So we want to get rid of this 9. So in order to get rid of the negative 9 here, we have to add 9 to both sides. And when we do that, these 9's cancel out, leaving us with 11x is greater than 13 plus 9, which is 22. Now, the next step would be to get rid of this 11. And in order to do that, we have to divide both sides by 11. And when we do that, the 11's cancel out, leaving us with x is greater than 2. Now, since our inequality is a greater than, we're going to do an open circle at 2. And it's x is greater than 2, so it's all the values to the right. And we draw our arrow and we shade that in there. And we have our solution and the graph for the solution. Now when we solve linear inequalities, we have to have both parts. We have to have the solution and the graph of it. So let's go ahead and take a look at our second example. And for this example, we have 7x plus 9 is greater than or equal to 10x minus 12. So the first thing we want to do is we want to get all the x's on one side. So let's go ahead and subtract this 10x over. And we subtract 10x to both sides. These 10x's cancel out, leaving us with negative 3x plus 9 is greater than or equal to negative 12. And now we want to try to start isolating x. So we got to get rid of the positive 9. So in order to do that, we subtract 9 from both sides. And when we do that, those 9's cancel out. And we're left with negative 3x is greater than or equal to negative 12 minus 9, which gives us negative 21. And then in order to get rid of this negative 3, we now have to divide both sides by negative 3. And when we do that, these negative 3's cancel out, leaving us with x. But here's where our rule comes into play. We just divided both sides by negative 3. So because we did that, we now have to flip our inequality. So it becomes a less than or equal to negative 21 divided by negative 3, which gives us a positive 7. So we have our inequality solution. Now we want to graph it. So what we're going to do here is, because our inequality is a less than or equal to inequality, it's going to be a closed circle at positive 7. There's our closed circle at 7. And we want all the x values that are less than that. So it's going to be everything to the left. So we draw our arrow. And we have our solution. Let me color this in a little bit more so you can see that there. All right. And there's my closed circle. All right. And we have both parts for this inequality. We have our solution and we have the graph of the solution. All right, so let's go ahead and take a look at some compounds now that we know how to solve simple inequalities. And our compound inequalities come in two different types. We have an and compound and we have an or compound. And you can see here on the left that we have basically three parts to our inequality here. And this is going to be what we call an and compound inequality. The one on the right here, we have two inequalities, but they're separated by the term or. And this is a or compound inequality. And the graphs of these two inequalities differ from each other. So let's go ahead and take a look at what the graphs of these would look like. So here we have negative 2 is less than or equal to x, which is less than 1. Now when we graph the inequality, we basically want to look at each separate inequality here. So negative 2 is less than or equal to x. Because it's a less than equal to, we're going to use a closed circle at negative 2. So we place our closed circle at negative 2. And then over here, x is less than 1. So our inequality is less than, which means that it's an open circle at 1. And with an and compound inequality, the solution is in between two numbers. So we would draw our line connecting those two, and that would be the graph of the solution. Because if you think about it, negative 2 is less than or equal to x, meaning that x is greater than negative 2, so it would be everything to the right of negative 2, but it's also less than 1. So our solution would be in between those two numbers. So let's go ahead and take a look at the or compound. For an or, we graph each one of these inequalities separately. So x is less than negative 1. Because it's a less than inequality, we use an open circle at negative 1. And x is less than that, so it's going to be everything to the left. And then for our other inequality here, we have x is greater than or equal to 2. Because of our inequality, we're going to use a closed circle at 2. And x is greater than that, which means that it's all the x values to the right. We draw a circle to our arrow to the right, and we have the solution for the graph. So you can see here that an and compound is in between 2 points, and an or compound is the solutions are going in opposite directions from each other. All right. So let's go ahead and take a look at how we can actually solve compound inequalities. Now, for our first problem, we have negative 2 is less than or equal to 3x minus 8, which is less than 10. And basically what we want to do here is we want to solve for x in the middle here. We want to get x by itself. So the first thing that we do is we're going to have to add 8 to get rid of this negative 8. Now, with an and compound, if we do it to 1, we have to do it to all three. So if I add 8 here, I got to add 8 to this side, and I add 8 to this side. So when I do that, these 8's in the middle cancel out here, and I'm left with negative 2 plus 8, which is positive 6, which is less than or equal to 3x, which is less than 10 plus 8, which is 18. Now, in order to get rid of the 3 here that's attached to x, I got to divide by 3. And remember, what we do to 1, we got to do to all. So I divide each part of that inequality by 3. And when I do that, those 3's cancel out. And I'm left with 6 divided by 3, which is 2, which is less than or equal to x, which is less than 18 divided by 3, which is 6. So we have our solution, and now what we want to do is we want to graph our solution. So 2 is less than or equal to x. Because it's less than or equal to, we're going to use a closed circle at 2. And x is less than 6, which means that we're going to use an open circle at 6. And because it's an or compound inequality, we know that our solution is in between these 2 points. So I'm going to go ahead and draw my line connecting those two. And we have the solution and we have the graph of the solution. All right. So this is an and compound. Let's go ahead and take a look at an or compound inequality. All right. Now with an or compound inequality, remember we have two separate inequalities separated by or. Basically what we want to do is we want to solve each one separately. Okay, so let's go ahead and look at this first inequality here. Negative 2x plus 3 is less than 5. So we want to go ahead and solve this for x. So in order to do that, we got to get rid of this positive 3 here. So we subtract 3 from both sides. And when we do that, these 3's cancel out, leaving us with negative 2x is less than 5 minus 3, which is 2. Now we got to get rid of that negative 2 that's attached to x. So in order to do that, we divide by negative 2. And when we do that, these 2's cancel out, leaving us with x by itself. But since we just divided both sides by a negative number, we got to flip the inequality. So now it becomes a greater than, and then 2 divided by negative 2 is negative 1. Now, it's very important that you watch for this rule whenever you multiply or divide both sides by a negative number. This is the number one reason people get inequalities wrong. Okay, so make sure that you pay close attention that whenever you multiply both sides or divide both sides by a negative number that you flip that inequality. All right, so we have our first inequality here. The second one, negative 4x minus 7 is greater than 9. We want to solve this one for x now. So what we do is we add 7 to both sides. That's going to get rid of our 7 here. So 7's cancel out. And we're left with negative 4x is greater than 9 plus 7, which is 16. And then in order to get rid of this negative 4 here, we got to divide both sides by negative 4. Those negative 4's cancel out, and we're left with x by itself. But remember our rule. We just divided both sides by the negative. So we got to flip our inequality. So now it's a less than inequality. And then 16 divided by negative 4 is negative 4. So on our solution for a or compound inequality, we're going to place or in between our two solutions, and that's going to give us our overall solution right here. So our solution for this is x is greater than negative 1 or x is less than negative 4. So let's go ahead and graph each one of these inequalities. Starting with our first one here, x is greater than negative 1. Because it's greater than, we're going to use a open circle at negative 1. And because x is greater than that, it's going to be all the values to the right. So there's the solution to that one. And then x is less than negative 4. We're going to use a open circle at negative 4. And x is less than that, so we want to do all the values to the left of that. And we have our solution and its graph. All right, and this concludes your solving simple and compound linear inequalities. So go ahead and get started on the worksheet and have fun.